Okay, we have an interesting integral today. We've got the integral of x to the 4th plus 1 over x to the 6th plus 1 dx. Okay, the tricky thing in this case is when we have even exponents and we're adding, the factoring becomes a little more tricky. We can't use difference of two squares. Some of the formulas don't really work, but one thing we can do here for x to the 6th plus 1, we could look at this as sum of two cubes. We can write x to the 6th as x squared all cubed, and of course we can write 1 as 1 cubed. And writing it this way now, we can use our sum of two cubes formula, so that's just going to give us x squared plus 1 for the first part, and then we're going to have x squared squared, which is x to the 4th, minus this x squared plus 1. And so what we can do is let's take this and rewrite the denominator, but when I do it, I'm also going to rearrange this numerator. So let's see how this is going to look if we write out all this stuff. And now what I want to do here is I want to rewrite x to the 4th plus 1 so we can get cancellation. I kind of need to just force cancellation out because it's still not going to be easy to deal with like this. So let me first in the numerator, let's create this piece right here. So we'll have an x to the 4th minus x squared plus 1. And then what I can do is we can add something in order to make this work. What I want to do is we don't have an x squared in this. So if I rewrite this as x to the 4th plus x squared plus 1, because then we're getting close because x squared minus x squared is just 0, so that's not going to bother us. But when we add up the whole thing, we have actually two copies now of x to the 4th plus 1. We have 2x to the 4th plus 2. All I need to do is multiply by 1/2 in front. And you may notice this right here was kind of inefficient, right? Because we really just needed to add x squared. I'm kind of just doing it to be stubborn and get a variation on the method, but you could just add x squared here, and that's going to be probably the quicker way. So then what I'm going to do here is I'm actually going to break this up into three integrals. First, we're going to have this first one with just this piece. So we're going to have 1/2 x to the 4th minus x squared plus 1. And then for this second integral, what I'm going to do is here, I'm just going to grab, I just want to grab the x to the 4th and the plus 1 just to mirror what we have in the original integral. So doing that, this one's just going to be x to the 4th plus 1 over the same denominator, but let's put it back. Let's write it as x to the 6th plus 1. And then I just have this x squared left to account for. We've already included everything else. So for the third integral, we still distribute in the 1/2, and this one's going to become x squared over x to the 6th plus 1. And then what's going to happen is this right here is going to cancel with this. We just have a 1 in the numerator. This is going to be easy. This is just going to be our arctan integral of 1 over x squared plus 1. We notice for this one right here, this is actually the same thing. If we put a label on our original integral, we got back the original integral here. So this is just going to be like 1/2 I. And this last integral here, this isn't too bad. We can actually do this with a substitution. So let me clean up the board and we can see if we can integrate this and finish it off. Okay, now with this, the first thing I want to do is just get rid of this. We have this extra copy of I, or 1/2 I. If I just subtract off 1/2 I on both sides, subtract off 1/2 I here, this is going to cancel off. And then over here, 1I minus 1/2 I, this is just going to become 1/2 I. Here, we could write it as like I over 2 there. But then actually, if we've got everything divided by 2 here, here, and here, if I just multiply everything through by 2, that goes away, and that goes away. And now we've isolated our goal, our solution that we want to find. Now here we can just do this part really quick. This is just going to become arctan of x. Over here, I want to do a substitution. I need to set this up first. For x to the 6th plus 1, I can actually write this as x cubed squared plus 1. That's going to help with the u substitution because the derivative of this is going to be 3x squared, so we're kind of close there. So if I say u is going to be equal to x cubed, then take a derivative, du is going to be just 3x squared dx. So then in order to set up this du, let's multiply in a 3 here. I actually forgot my dx, let's put that back. And then I don't want to change this, let's multiply by 1/3 in front. So then we'll go ahead and substitute here, and I'll bring it down with this arctan. So we're going to have this 1/3 in front. The integral is going to transform with the numerator being du. This is going to become just du over u squared plus 1. Integrating this, bring along the arctan. This is going to become 1/3. This is just our arctan formula again, but in u. So this is just going to be arctan of u. All I need to do is just back substitute in order to finish this thing off. So for my final solution to this, we just get arctan of x plus 1/3 arctan of our u, which is x cubed, add a plus c on there, and that's it. Okay, there you go. Not too bad. Just kind of a slightly inefficient method. I kind of added a little twist there. But anyway, still worked out pretty nice. Thanks everyone for watching today. Have a good day.